Welcome back to the Michigan Business Beat on this Wednesday, December 21st. I'm Chris Holman, and you're listening to us courtesy of the Michigan Business Network. Don't forget to get to that site, michiganbusinessnetwork.com. A lot of important information for all of you. And log your events, please, on the statewide calendar. Everybody's dying to know what you're doing. And right now we're going to find out what this guy is doing. Phil Lewis, he is the Technical Engineering Manager at Dynamic Intelligent Solutions in Clinton Township, Michigan, and that's down by the river, is it not, Phil?
Well, it's off of just off the Lake St. Clair over in Macomb Township, Macomb County area. So we're kind of off the river, off the lake.
There you go. Great. So no beachfront here, but a lot of engineering going on. Tell us a little bit about your company, Technical Engineering Manager Phil Lewis.
Absolutely. Well, Dynamic Intelligent Solutions is a startup business for the automotive testing industry. And we started in early 2011 with just an idea on how to help the current testing market for automotive testing parts by using 3D optical systems. So what we're capable of doing is taking 3D optical cameras and measuring how parts change during a test, such as an environmental climate test or even a stress test or some type of life test that we do. That we typically do on parts for the automotive industry. So we do a lot of high tech things here.
So tell us a little bit about the like anecdotally. What are the products? Would you be testing like a piston and how it holds up under the stress of the heat, the energy?
Well, that would be one thing we could do, but we typically do a lot of exterior and interior components on a vehicle. So all your plastic pieces, your car doors, your instrument panels, your exterior panels, etc., that change based on applied loads. So if we were to heat up an instrument panel inside a climate chamber, these are typical tests that they do in the industry to see if there's gap changes, if the instrument panel bows too much, if components stretch too much. These are typical things they do in the industry. What we do is we introduced 3D cameras inside that measurement area so we could physically see how the parts are moving and have a high extreme accuracy on calculating what those components are doing at specific intervals of time and at specific temperatures too.
So your primary customer right now is probably the automotive industry, but these extreme stress circumstances, I guess, wouldn't be all that applicable to the normal driver, right?
Not to the normal driver necessarily, unless they walk out of their car, they walk into Walmart, and 1 hour later they come back in their car and their glove box is open because of heat during the summertime.
Okay.
So those are the things that that the testing industry tries to do, is try to build and engineer a product that sustains those type of lifelong durability issues. And what we do is we're able to bring 3D technology into that testing environment to really see what's going on during a product's heat up and cool down cycle. And I can quickly go into just quickly tell you how the traditional method of today is. Today, if an engineer builds a part or an automotive industry builds a part like an instrument panel, they come to a test lab. They put that. What they do is take that instrument panel and they physically measure maybe 15 to 20 points on the instrument panel with a machine. They then put it inside a climate box, heat this thing up for 3 days to 10 days, make it really cold for 3 or 10 days, or make it super humidity for 3 or 10 days. Then they pull that thing back out, they put it back on this machine and remeasure those same points and same locations to see if there's any changes. So what the problem that we saw is they're missing what's going on during those 3, 10, 15-day cycles. They're not doing anything to it. They're just letting it sit in a climate box. So we've taken cameras and put them in the climate box. So now we can really see and use these cameras to measure how and see how that actual component is changing during the entire cycle.
Well,
so there's no more put it in, wait, and then take it back out. We're able to capture dynamic movement throughout the entire process.
So you're really changing the industry in the way it tests.
Absolutely,
yeah.
Absolutely. And
Well,
startup.
congratulations. As a matter of fact, you guys just were first place winners in an automotive competition.
Yep, absolutely. We just won the first place for the 2011 SAE MITEF automotive competition for the Innovator of the Year. We went up against a plethora of companies here, and we came down to the last 5 back in November. We went into the San Marino Club in Troy, Michigan to do our big finals event, and we ended up taking first place.
Wow. Congratulations.
Yep.
That is really cool stuff. And, of course, this type of thing would be applicable to other industries as well. I mean, you could easily get into defense contracting and things like that, I would think.
Absolutely, and that's the goal. As starting our system and our 3D measurement technology since late last year, we've really started blowing up with the industry. And once people and engineers in these companies understand that how we can test their products with these camera systems, they just say, hey, can you do this? And then all of a sudden the ideas start flowing, and it builds onto our original idea.
Wow. Congratulations. No kidding. Phil Lewis, Technical Engineering Manager at Dynamic Intelligence Solutions in Clinton Township. Keep up the good work, my friend, and keep us abreast of what's going on, eh?
Great. Thank you very much, Chris.
Appreciate it, Phil. You're listening to Michigan Business Beat on the Michigan Business Network. I'm Chris Holman. It is Wednesday, December 21st, and we'll be right back with more.